Let's look at the following example. A metal tank begins filling with water, and there is a constant rate of change of the tank and water's weight in pounds with respect to the volume of water in the tank. So we'll let W represent the weight of the tank and water together in pounds, and we'll let V represent the volume of water in the tank. Now, since there's a constant rate of change of 8.35 pounds per gallon, we know that the ratio of the change in weight to the change in volume is always equal to 8.35. Now, we're also given that when there are 17 gallons of water in the tank, the combined weight of the tank and water is 164.55 pounds. And this statement tells us that when there are 17 gallons, so when V equals 17, the weight is 164.55 pounds, so W equals 164.55. Now, if we want to write a formula that expresses W in terms of V, we can use the general linear function formula, which would look like W equals M times V minus our reference value for V plus our reference value for W. Now, we've got some reference values. We know that our constant rate of change is 8.35. We know that our reference value for V can be 17. We know that our reference value for W can be 164.55. So our formula would then be W equals 8.35 times V minus 17 plus 164.55. So let's go ahead and plug that in. Cool. So now let's answer some questions about how we determine W given a value for V. So next question, what is the combined weight of the water in tub when the tub contains 34 gallons of water? Well, first of all, if the tub contains 34 gallons of water, this means that V equals 34. V equals 34. And we can use our formula that we got before and plug V equals 34 into it to compute the value of W. So when V equals 34, the weight of the tank and water is going to be equal to 8.35 times 34 minus 17 plus 164.55. So let's go ahead and plug that in and give it a shot. So this tells us that the total weight is 306.5 pounds. Now we check that and we get a green box. Now the other two questions you can answer similarly. Now let's look at the final question. The graph of W in terms of V is shown below. Part A asks, what does the graph of W in terms of V represent? And we know that graphs represent all possible pairs of values, so all possible pairs of VW values. In part B, which VW point on the graph represents that the tub and water weigh 206.3 pounds when there are 22 gallons of water in the tub? Now again, if we look at the weight of tub and water weigh 206.3 pounds, this means W equals 206.3. And if there are 22 gallons of water in the tub, this is V equals 22. So the VW point that represents this information is 22, 206.3. So 22, 206.3.